We have been focusing on slope-intercept form of equations, and today we're going to talk about a new form. This is on your formula chart called point-slope form. So this this y equals mx plus b. This is the slope-intercept form. I'm not sure why there's an extra line there. Oh, I've already filled in the word there. Because the two things that we need for the equation are the slope and the y-intercept. Make sure that is the y-intercept, not the x-intercept. Another form of the line is called the point-slope form. This form is best used when we are given a point and a slope. That xy point, meaning it is not a y-intercept. Hence the name. And this is on our formula chart. So it says that y minus y1 is equal to m times x minus x1. Now things I want you to keep in mind, this y and x, these are going to stay. They stay a y and an x. But you can use your x1 and y1 to go here and to go here. X1 and Y1 again come from that given point, and M is your slope as always. So I'm going to do one with you, and then I'm going to ask you to do one to practice. I do want you to be aware that we can put this in Y equals format. So if I have Y minus Y1 is equal to M times X minus X1, and when we talk about that whole shifting thing that we've done before, we can change this to y equals, we can say y equals m times x minus x1 plus y1, and that's going to show you that shift. We talked about insiders lie because this is a minus, and then this y1 is going to be your vertical translation. So let's try one here. We've got write the equation point-slope form. And then change it to slope-intercept. So we're going to start in y minus y1 equals m x minus x1. And we're going to change it to y equals mx plus b. So here's my x1, here's my y1. And we're just going to plug them in. We're going to plug these things in. So I have y minus y1 is here. 1 is equal to a negative 5 over 2 is my slope. Make sure you have that negative. X minus and x1 is 6. Now if x happened to be negative, then this would be a double negative to become a positive. So we know that we need to distribute. So we're going to say y minus 1 equals negative 5 over 2x. Negative times a negative is a positive. 5 times 6 is 30 over 2, which is 15. And then, look, we're almost in y equals mx plus b. We need the y by itself, so I need to move this negative 1 by adding it. I cannot add 1 to this negative 5 over 2x because this 1 doesn't have an x. So I get y equals negative 5 over 2x, 15 plus 1 is 16. And now I can see my slope has not changed. So my slope is still negative 5 over 2 if I wanted to graph that, and my b is 0, 16. So I would like you to try example 2. And then on the back here, what happens if I just give you 2 points? Well, we need to first find slope, which we can do. We've done that before. Change in y over change in x, or you can make a mini table. I'm going to go ahead and use my y2 minus y1 over x2 minus x1 formula. So I'm going to say 5 minus 3 over negative 8 minus 6. 2 over negative 14 is 1 over negative 7. Now it doesn't matter which coordinate you choose. I'm going to go ahead and choose this first one. It's all positives. That's just easier. I'm going to say y minus y1 is 3. So y1 was 3 is equal to my slope of negative 1 over 7 times x minus x1 is 6. So again, I'm going to just distribute y minus 3 Negative 1 over 7 times x is negative 1 over 7x. Negative times a negative again is a positive. And now I just need to move my whole number, so plus 3. Again, you're not going to put that with your slope because it doesn't have an x on it. 3 plus 6/7 is 3 and 6/7. So I can see again that my slope is negative 1 over 7, meaning it's going to descend, and my b value is 0, 3 and 6/7, so not quite 4. I would like you to try this as example 3 again. It should actually be 4. And we'll go over it in class.